Hello everyone, welcome to DevOps Pro English channel. In the last video, as I mentioned, we will dive into the concept of variables. And the concept of variable is quite extensive. So covering it all in one video is a bit challenging. That's why I have divided it into two parts. And this is going to be part 1, where we will begin to understand variables. Now, for those of you who already have some coding experience or who are familiar with programming languages, you probably know what variables are and their use cases. But there might be some beginners out there who are not sure what variables are and how they relate to Terraform. So let's start by explaining what variables are and their role in Terraform. So whenever we write code, or let's say we are writing code in Terraform, and there is a certain static value that is being used repeatedly. For example, let's say we have some Terraform code and there is an IP address that's being used multiple times in our code. Then one approach would be to hardcode this value everywhere we want to use it. But what happens if the value changes in the future? Then we will have to go back and manually replace it everywhere it's used, which increases the chances of making mistakes, and in the real world, this isn't an efficient way to work. This is where variables come into play. We can think of variables as a container with its own unique name and a value inside it. Whenever I want to use that value in my code, I simply refer to its name, and the code understands that I am talking about the value I assigned to it. So let's say in this case, I decide to change the value tomorrow. I would only need to update it in one place, and whenever I use its name in this code, it will automatically understand and use the latest value when the code runs. This is known as dynamic value assignment. In other words, we create a variable with a name, assign it a value, and whenever we want to use that value in this code, we simply use the variable's name. So by now, I hope you understand what variables are and their purpose. However, many of you might be wondering where exactly we will use variables in Terraform. So to find the answer, let's turn to Terraform's documentation. Today, we will create an security group using AWS Security Group resource, and in this process, we will also delve deeper into the concept of variables. If you are not familiar with what a security group is, don't worry. Just like how we have been creating AWS EC2 instances so far, and we know that an EC2 instance is a virtual machine, so I can control where and how traffic is allowed to and from those machines by creating a security group. Let's understand this with another small example. Imagine we have 3 team members, and I want to ensure that if I create a machine, an EC2 instance, and it's running an application on a specific port, only these 3 team members should be able to access it. Nobody else in the world should have access to it. So I will allow the IP addresses of these 3 members in the security group to ensure that only they can connect to that instance on that specific port. I can also control where traffic can go from that instance using the security group. So this is what a security group is all about. Now let's go to the AWS console and try to create it manually so you can easily understand what resources are used and what they can mean. To create a security group, you will need to go to the console and search for EC2. When we usually create EC2 instances, we go into instances. But since we want to create a security group now, you will find network and security right below. Click on that. Next, you will see the option to create security group. This is where we can create a security group. But to do this, you will need to provide a lot of details step by step. So let's break it down. The first thing you need to provide is the security group name. You can give your security group any name you prefer. The second option is for a description, where you can provide some details about why you created the security group, so you can understand its purpose in the future. The third option is to provide information about the VPC, Virtual Private Cloud. VPC is a complex topic in AWS, so for now, we will stick with the default VPC ID that is shown here. Now let's move on to inbound rules. Inbound means from where you want to allow incoming traffic. Here you will see various fields like type, protocol and port range. In the port range field, you can specify which port you want to allow. For example, if you want to allow port 8080, you can enter it here. Now you will see the source information field. In the source information, you provide the IP address from which incoming traffic is allowed. Going back to our previous example where we wanted to allow the IP addresses of the team members A, B and C, you would enter their IP addresses here. This way, it will only allow incoming traffic on port 8080 from those specified IP addresses. There is also an optional description field where you can add any additional information or notes if you want. So this was an overview of inbound rules configurations. Just as there are inbound rules, there are outbound rules. Just like inbound means from where incoming traffic can come, outbound rules determine where traffic can go and from which port numbers and on which IP addresses it can go. The last option is for tags, which is optional. Here you can assign any tags to this security group if you wish. So all this information is required to create a security group. To finalize the creation, you can click on Create Security Group at the bottom and your security group will be created. This is how we can create a security group using the console. Now let's go back to the documentation and understand the resource for creating a security group. Most of the things in this resource should be quite clear to you now since we have already seen them in the console. You will find similar details here like the name, description, VPC ID, ingress, inbound rules, including description, port number, protocol, CIDR block, which means the IP addresses we want to allow. And below that, you will see egress, outbound rules, and tags. So this is all the same information that we provided manually when creating the security group one by one in the console. And all these details are being provided to this resource so that Terraform can use them to create a security group in AWS. This resource is used to create a security group. While looking at this resource, I am reminded to something very important that I would like to cover here. As we can see, arguments like name, description, and VPC ID are part of this resource. It's not mandatory to provide all these arguments. Even if we remove these three, Terraform will still create something according to its default behavior. But you can't just remove anything randomly. You need to know what arguments are required to create a resource and what arguments are optional. And for the optional ones, you can remove them. After removing them, Terraform will use the default values for those arguments and create your security group or whatever resource accordingly. To find out which arguments are required and which are optional for any resource, you can scroll down in this documentation and you will find the argument reference section. In the argument reference, you will see a list of all the arguments that this resource can support. It explains what each argument is for and importantly whether it's an optional or required. For example, you can see here that description, ingress, egress, name, tags and VPC ID are all optional. This means that even if you don't provide values for them when creating the resource, the Terraform use its default values and create this resource accordingly. Below, you can see the ingress section, just like we saw the ingress block above. It lists the arguments supported within it and indicates that they are required. So if you want to allow incoming traffic, you must provide values for these required arguments. This way you can read and understand which arguments are necessary and which are optional for creating any resource. You can then customize your resource creation by providing the arguments that match your specific requirements. And you can leave optional ones empty if needed. So let's get back to this resource and we will create a security group while also understanding the concept of variables. First, let's remove the description and VPC ID from this resource because they are optional. Even if you don't provide them, Terraform will use its default values and create the resource. Similarly, let's remove the description from within the ingress block. We will skip IPv6 CIDR blocks from now because they are optional. While CIDR blocks are also optional, but we will keep them as, because we will use the concept of variables specifically for EC2 instances. Now let's copy the ingress block multiple times and change the port numbers for each copy. For the CIDR blocks, let's provide a random CIDR block for all of them. In simple terms, this means we want to allow incoming traffic on all these port numbers from the same IP address. Once we have our code ready, let's comment out the EC2 instance creation code and run the Terraform plan. In the Terraform plan, you will notice that there is a new resource being added, which is our security group. And inside this security group, you can see one egress rule and 4 ingress rules. So let's proceed to apply this plan and see how our security group is created in the AWS console. Now our apply is completed. So let's go back to the console and check the security group. Inside the security group, you will see the same 4 incoming rules that we defined in our code with the same port numbers and IP addresses. So we have successfully created a security group using Terraform. However, did you notice that we are using the same CIDR block IP addresses multiple times in our code? So if for example that IP address changes in the future, we would have to go into the code and have to change it everywhere, which is not an efficient or practical approach in the real world. This is where variables come into play. So let's go ahead and create a new file named variables.tf, where we will define all our variables. To create variables, you first need to use the variable keyword followed by the name you want to give to your variable. For example, if we are creating a variable for CIDR blocks, we can name it CIDR and enclose it with brackets. This defines our first variable. After defining the variable, you need to go into your file, and whenever you have used an IP address, you will replace it with var.cidr. Now let's save this file and run Terraform plan. When you run Terraform plan, it will first ask you for the value of the var.cidr variable, because so far we have only defined the variable in the variables.tf file, but we haven't assigned it a value. So as you run the Terraform plan command, it will prompt you for the value of this variable. Go ahead and provide a random CIDR block for now and let the plan run. Once the plan is executed, you will see that wherever we had used the CIDR block, the value from our variable has been substituted in all those places. So this was our first method for assigning values to variables. Besides this, there are many different ways to assign values to variables. So let's take a quick look at this each method. In the second method, we can directly provide the variable's value when running the Terraform plan or Terraform apply command with the -var flag followed by the variable name and its value. So this was our second method. But if you don't want to use both of these methods and prefer to set a value in advance, you can assign a default value to the variable where you declare it in the variables.tf file. After setting a default value, when you run the Terraform plan command, Terraform won't prompt you for a value and it will use the default value you provided. So these are some of the ways by which you can assign values to Terraform variables depending on your needs and preferences. You can also assign values to Terraform variables by using environment variables. To create environment variables in Linux, you can use the export command along with the tf_var_ your variable name and provide the value you want to assign. For example, in the Linux, you can run export tf_var_CIDR equals to your CIDR value. Then, when you run Terraform plan, you will see that the value you assigned to the environment variable tf_var_CIDR is used as the value for the var.CIDR variable throughout your Terraform code. Now, let's discuss the last option for assigning values to Terraform variables, which is a common approach used in the real world. But before that, I would like to mention that if you want to download Terraform or Kubernetes nodes, you can join our DevOps Pro membership at DevOps Pro channel, where you can access and download nodes for every video. In the real world approach, we declare variables in the variables.tf file as usual, but assign values to them in a separate file named terraform.tf_vars. The file name must be exactly terraform.tf_vars, and in this file, you simply list the variable names and provide their values. After providing values in the terraform.tf_vars file, when you run the Terraform plan command, you will see that the values you specified in the terraform.tf_vars file are now being used throughout your Terraform configuration. This is a standard approach commonly used in the real world. You declare your variables in the variables.tf file, and for assigning values, you create a separate file named terraform.tf_vars and provide values for those variables there. In addition to this, I would like to mention that in real world, you don't typically declare all your providers in a single file, nor do you write all your resource code in one file. In a real world scenario, each piece of code has its own file and there is a proper naming convention followed. For example, we created a separate file named variables.tf to define variables and another file named terraform.tf_vars to assign values to those variables. Similarly, for declaring providers, you can create a file named providers.tf and provide the information about the providers you want to use. So let's go ahead and create a new file named providers.tf and put all your providers information inside it. Now, all left code in our file is creating the EC2 instance resource and the security group resource. We will separate these into two distinct files as well. For example, the file is already named ec2_instance.tf. So we will create a new file named securitygroup.tf and move all the code related to the security group creation into that file. So we now have 5 Terraform files, each with its own specific code following a proper naming convention. This is how things are typically structured in the real world. It's a good practice to start adopting this structured approach now. This way, you will have a well-organized and modular code base. If you need to add something new in the future, like a new variable, you will know exactly where to go, like variables.tf. Or if you need to change providers information, you can do it easily in the providers.tf file. Following this structure, make it easier for you and your team members to work on a code base and make changes as needed. And that concludes our Terraform variables part number 1. I hope you have learned a lot of new concepts today and enjoyed the learning process. The most crucial thing is to practice what we have learned today and what we will continue to learn in upcoming videos. Because without practice, you won't become a master of Terraform. If you have any doubts, please feel free to ask in comment section. If you found the video informative, don't forget to like it, share it with as many people as you can, and subscribe to the DevOps Pro English channel. For those who prefer to watch videos in Hindi, you can check out our DevOps Pro channel. With that, we conclude this video. See you in the next one. Thank you.